All right, let's do a vocabulary review for section, we're going to start with 5.5, Indirect Proof, and this is a review of vocabulary. Okay, so let's draw a line indicating in column A, what's a contradiction to column B? Well, if X is less than Y, then it's a contradiction for the first statement here, because the hypotenuse is X, it has to be larger than Y. In the next picture, both radii are equal, so that can't be true. And here, the ordered pair X equals Y, so that can't be true. All right, X equals Y. The only contradiction here is this triangle, because X has to be greater than Y. And then again, so this has to be contradiction here and contradiction here. All right, we're going to learn about indirect. Indirect means not direct or in course or in action, taken a roundabout route to get to a point or idea. So in direct reasoning, all possibilities are considered and then all but one are proved true, false. The remaining possibility must be true. So the indirect way from school takes a lot more time. By finding the negation of a statement false, we indirectly prove the statement true. So the steps in writing an indirect proof, we're going to start off by temporarily assuming the opposite of what we want to prove. We're going to show that a temporary assumption leads to a contradiction somehow. And then we conclude that this temporary assumption must have been false, therefore proving what we wanted to prove true in the first place. All right, so let's start off baby steps here. Suppose we want to write an indirect proof of the statement. As the first step of the proof, what would we assume? So triangle box is not acute. What did we want to prove? We want to prove triangle box is acute. What is the opposite of this? Well, triangle box is, oh, I'm sorry. We want to prove that it's not acute. So let me erase this. Is not acute. So the opposite of not acute is acute. So our first step in our proof, the very first step, is we're going to assume temporarily a triangle box is acute. Okay, so let's try some more. So at least one of the items costs more than $25. We want to prove that at least one of the items costs more than $25. So that means n is greater than 25. The opposite of that is n is less than or equal to 25. So we're going to assume temporarily that at least one of the items costs at most $25. All right, so if I wanted to prove AB equals CD, our first step would be to assume temporarily that AB does not equal CD. If I wanted to prove that the sun is shining, my first step in an indirect proof would be assume temporarily that the sun is not shining. Okay. All right, so which statements contradict each other? Triangle AYZ is acute, it's scalene, or it's equal angular. Well, what does it mean to be acute? All angle measures measure less than 90 degrees. If it's scalene, all sides have unequal measure. And if it's equal angular, all angles are congruent. And that means all sides have equal measure. So the ones that are in contradiction are scalene and equal angular. All right, let's practice doing an indirect proof. So if I was given the 7 times the quantity x plus y equals 70, and x does not equal 4, we want to prove y does not equal 6. So in the indirect proof, step 1, assume y equals 6. We're going to assume the opposite of what you want to prove. All right, first step, this was given. So then we're going to use this information and substitute in y, 6 for y. Then we're going to use the distributive property. And then we're going to subtract 42 from both sides. Then we're going to divide both sides by 7. All right, now, I'm about done, but I'm going to remember there was another piece of given information. And notice what happened here when I put that in the proof. I contradict each other. So statements 6 and 7 contradict each other. Reaching a contradiction means the assumption was wrong. Thus, I can prove the opposite. Okay, so suppose you want to write an indirect proof for the following statement. As the first step in the proof, what would we assume? Well, if I want a quadrilateral ABC has 4 right angles, what's the opposite of that? That's not the opposite, that's not the opposite, that is the opposite. Okay, all right, so what did my classmate do wrong? Assume temporarily angle A is acute when I wanted to prove angle A was obtuse. So why is that wrong? Well, what's the negation of being obtuse? Okay, so angle A is not obtuse. What does that mean? Well, it means angle A is acute, or it could mean angle A is right. So the indirect proof has an incorrect assumption because the opposite of angle A is obtuse is it's not obtuse. And that's the end of this section.